Everyone, given a sorted array and an integer, find the position at which k is present in the array using binary search. So here I inputs are an array and an integer value, and the output uh, is an integer which represents the index of the value that matches with the given integer. So first, let's understand what is binary search. Binary search is a search method. Uh, it is an algorithm which used to make the search efficient. Uh, it starts like, for example, if you see this array, take this array as an example. Here there are 5 elements. This search algorithm starts with 1 and the ends at 5. It takes the start element and the end element, and uh, it checks the middle value by dividing the starting and the ending index. The starting index is 0 and the ending index is 4. Uh, if we add both these and divide by 2, if we take middle for the start and the end, it will come 0 plus 4 by 2, 2. So if it will take the second index elements 3 and checks whether this matches with the given integer. If not, if this matches, we can return this index as the output. If not, we should check whether this is greater than or equal to the given integer. So since it is 3, 3 is less than 4. So here they are already given that the array is in a sorted array. They are given as a sorted array, so it will be in the ascending order. So if 3 is less than the given integer, uh, we can reject these elements, right? It is fine to check these, consider these elements, because uh, as this is in ascending order, uh, this 3 is less than 4, so less than 3 elements are also less than 4, right? So we don't need to check these elements, so we can move the starting index value to the element that is next to the middle index. So it will come 4, and the end index will be 5. It will checks the take these two, which is 3 plus 4, and divide by 2. 7 by 2 will come 4. So it takes 5 and checks whether this is less than or it is equal to the given integer. It is not. It is greater than the 4. So now, if the element is greater than the given integer, we can reject the right side path. So we don't need to if 5 is greater than 4, then the next elements after the 5 are also greater than 4. So we don't need to check the right side elements. So we can reject this and move on to the next left side elements. So we need to move the end index value to the middle -1. Now the middle is 5. So if we move the index value to -1, it will become 3. That is third index. So and starting index will also be the 3. Now if we add start and end index and divide them by 2, it will return 3, the same this element. So now it checks whether this matches with the given integer. It matches, so we can return the index number as 3. Now let's try to program this logic into the code. So first we need to declare a variable start. This should be 0 because here they are given the 0 based indexing positions. Then we need to declare n variable. This should be the end index value of the array. So this should be the length of the array minus 1. Now we need to get the middle index value by adding start and end index and then dividing them by 2. Now we need to loop through each uh, loop through the elements in the array to check whether that matches with the k or not. Let's use while loop. So the n condition should be uh, the start index should be less than or equal to the n, because as we seen in this example, uh, the start index and end index are equal at the end part. So if those both are greater than, we don't need to check that one. So we should check until the start index is less than or equal to the end index. Now we need to check we need to change the middle value in each iteration, right? For that we are reassigning the middle value here. Start plus end index and then dividing them by 2. Now we need to check whether the array of this middle index value is equal to the k or not. If this is equal, um, then we can return the mid value. Also here they are given a note, if multiple occurrences of the same number in the array is given, if multiple occurrences of the same number are there in the array, then we need to return the smallest index value of that number. So um, once uh, once the value matches the elements in the array matches with the k, we need to uh, check whether there is any element in the left side part, that is left side part of the mid index value, uh, because those are the elements that are smaller than this those are smaller than this middle value, right? Middle index value, right? So we need to check whether there is any small uh, whether there is any value that is same as this array of mid value. If that is same, we need to uh, we need to change the end index value as the mid index value minus 1. Also, if we return, this loop will break here, so we don't want to break here. So we can declare another variable as res, and the initial value for this one, let us give it as -1, because if there is no element that matches with k, let's give it as -1 as given in this example. Now here, instead of return, we need to use res variable to store mid value. and then we need to check the left side of the mid index value. If this condition fails, if the array of mid value is not equal to k, then we need to check else if array of mid value is less than k. If the array of mid value is less than k, then we don't need to check the left side of the mid value, because if, for example, if 3 is the uh, array of mid value, that is less than k, that is less than 4, then 2 and 1 are all will also be less than 4, right? So we can reject this part and we can move the start index value as mid plus 1. Then next final condition, when the array of mid value is greater than k, if that is greater, then we can reject the right side part of the mid value index. So we can move the end index value as mid value index minus 1. Then finally we need to return the res variable where we stored the mid value. Let's try to run this code. Yes, that's it. Thank you.